Hello, this is a presentation on a scaled Doppler sound sensor. We are iSound 3 and consist of Sam, Joe, Trent, Hien, and Chris. All right, the focus of the project was on infrasound, more specifically an infrasound sensor that could be used for search and rescue operations or navigation in GPS denied environments. And our project focused on using the Doppler effect to find the min and max peak of an incoming sound wave and finding the direction of said sound wave using the Doppler effect. And then we wanted to scale our project down to audible range so that we could test it and build something reliably, and hopefully in the future we could scale it back to infrasound.
The motivation for this was the goal of the whole project was to expand on previous research and solve a small piece of the puzzle that is infrasound, and create a device that could assist or improve the process of pinpointing a specific location without using global satellites, signals, and using fewer sensors. The engineering disciplines that we utilized was digital signaling and processing, which was filtering out background noise and analyzing specific wave peaks that we were looking for. The next part was embedded systems, using a controller and a driver to control everything. And the next phase was wave physics and using Fourier transformations to make everything more compatible and so that we could pinpoint exactly what we were looking for.
So our theory was that if there's a constant source of sound being emitted and we were to spin a microphone, what we would be able to do through analyzing that audio recording is confirm the overall presence of that signal at 300 hertz. And then through analyzing smaller segments of it and iterating through that audio file, we would be able to identify points where the microphone was heading towards that sound source and away from that sound source, because it would have the Doppler effect of either causing compression and an increase in frequency, or expansion and a decrease in the frequency.
So this is our physical device. On the left, you see the Raspberry Pi that attaches to our sensors and controls. The Raspberry Pi goes into the top part of this part in the middle, which we intended to 3D print before the coronavirus. Obviously, because we weren't able to access the school stuff anymore, we weren't able to print it very well. The Pi goes into the top, connected to LEDs for the directional read. The middle part contains the battery, which connects up to the Raspberry Pi, and this hole here allows the microphone to be fed out and spun about. Now that all sits on top of a handle that clamps onto it, but allows enough room in it to spin, causing the whole top piece to rotate when you swing it.
For the system, so this is our system architect. We have at the exterior part, we have an LED screen, we have a button, a microphone sensor, speaker, and a battery. So once you push the button, the signal would get captured. It would perform a signal analysis, determine which direction is at its peak. Then it would output that direction onto the LED screen with an arrow pointing which way you should go.
We had really early results with some early prototyping that we were able to do. We set up a home theater system and we played a 300 hertz tone, and we built a quick prototype that allowed us to record that audio file while swinging an overhead microphone. And we analyzed it and we confirmed that we were able to read a frequency of 300 hertz, which was the predominant frequency in the whole audio recording. And then we began to iterate through small chunks and analyze those using the Fourier transform. And we were able to find that there was a peak and a trough. And when we located the first one, the peak, we were able to calculate where the expected trough should be and the frequency, and we were able to locate that and verify that it worked.
All right, for future improvements, we hope to make the be out of better materials such as carbon fiber, scaling it back to infrasound frequencies, and maybe implement a drone in doing that, and also improve the user interface.